In a world yearning for change, there exists a community of visionaries and innovators, united by a common goal: to solve Earth's biggest challenges. From climate action to quality education, we're tackling all 17 Sustainable Development Goals reassembled as 10. We embody sustainability, unity, and empathy. Our character and reliability shine as beacons of hope. As role models for future generations, we're building a world where wisdom and consciousness rise, harmonizing life with nature and all species. Join us. Together, let's create a balanced, sustainable future for all.
Hello everyone. So happy to be here today with you, TLR community, and sorry for a little bit of delay. Technical issues can happen. Today it's such a special day because we are, I see, streaming on both LinkedIn, YouTube without any issues. This is a good thing, but we celebrate so many things today. One of them is obviously for all of our Muslim friends, and we have them in part of our community, and I believe we have all major religions in our community, and this is such a one of the main aspects of our mission, that we want to unite globally. We want us to become a global species where we truly understand each other and we can celebrate each other and what we believe in, and we can find the scope, we can find a narrative, a future narrative where we can all align on to create something better, not just for us, but also for the future generations. So that being said, Eid Mubarak. I know that you just finished 30 days of Ramadan, and that's a special day for you. Or I hope you will enjoy today our session where we have a global community of people aligned in the same mission to solve the SDGs sooner. And today we released our consensus document, the first product after the summit, where we aimed everything that we learned through our March Summit, the intersection of climate, AI, and humanity. And we put it inside the document. This is the first, let's say, comprehensive version that we shared today inside our newsletter. We also requested for you to start the process of movement from LinkedIn to our Beehive newsletter subscriptions, because this way we can control that you receive all the newsletters and we can create something more sustainable for the long run. And so that being said, we shared the link. I hope that my colleagues will share it also in YouTube and on LinkedIn, the link to where you can also download the consensus document in case you didn't had it in your newsletter. We invite you to subscribe to it. And moving further, we also announced the winners of our refill quiz. So those of you who during the summit and after the summit completed the quiz that we prepared about where you are on your climate journey, and this was such a revealing quiz, it's still open, so you can take it and you can get the Climate Guardian badge from Tech Leadership Lab until October, our next summit. We also had our winners announced in today's newsletter in both versions, on LinkedIn and through Beehive. And so this is absolutely super interesting. I won't share it, just the emails here in case you didn't read the newsletter yet and you are not subscribed. And just for those of you who were part of the summit and completed the quiz, we had 4 prizes. And the first one was gained the pizza on the house. This is the email address for all the winners. I'm just sharing it here very quickly because every one of you will be notified through email as well. And we know Mutambe Karaoke because he was part of the summit as one of the amazing entrepreneurs. So you got lucky with a pizza. A pizza goes to Kenya. So this is something with we knew before. Then we have an Amazon gift card that goes to this email address that will be also notified by us through email. And then the third one, it is a LinkedIn promotion branding service bundle from Dries Mascouti, who is also our community and now marketing manager. And he just celebrated Ramadan. So again, Eid Mubarak to everyone. And here, 90 minutes with me, and here you will have a choice with what type of consulting you will want to have. And with that being said, let's just get to our today's post-summit dialogue, because this time we have a different discussion that makes me very, very excited, because if we nail it and if my intuition was right, we might get to see a very, very interesting combination that could create that kind of global impact we at Tech Leadership Lab are aiming, if we manage to unite technologies, ideologies, and different industries to the grid. In my view, if we manage to put together what we have today as technology, as desire for a better sustainable future, I think we can manage those 2030 goals. I truly do, because during all this process, I discovered so many options we already have available. So it's not a matter of having what we need, it's a matter of consensus, it's a matter of uniting the agendas, or just feeling that this is unacceptable. And this comes from Professor Susan Krumdieck. And we have two amazing speakers. You saw them both at our event and at our summit. I will just present them a little bit, because would love to hear them speak this time more, because I prepared tons of questions we would want to go through, but through a dialogue form. Professor Dr. Susan Krumdieck, you are absolutely amazing. I saw most of your speeches. You, through the time, you managed to become a storyteller. And this is so unique in, in the industry, especially between engineers. You realize that the common and interesting narrative can bring people forward. And because of that, you created a narrative around the sustainable options we have. And you are one of the pioneers in transition engineering, or energy transition engineering. And basically, you're even inside Wikipedia. If you are searching transition engineering, you are named as the first pioneer in 2010, when you received distinction from the New Zealand ministry, or something similar, where you created a project for 50 years about how New Zealand could transform to be sustainable in the future. So you do have this kind of expertise. You do have a movement of transition engineers around the world, and you do have a say about what we need to do to become sustainable. I'm super, super happy to have you. Just a couple of words you might want to add to what I just said.
Right. Well, it's funny you mentioned that project from long ago, which was a United Nations funded project to get, I think it was 20 top sustainability thinkers from different backgrounds together to map out the 50-year journey to sustainability for New Zealand. And that's when I came up with the first story, because you have the best people in the room, the most dedicated people with really good, knowledgeable backgrounds, two engineers. And we can't talk to each other. It's a disaster. And the image just popped in my head of the story of the 7 blindfolded wise men and the elephant. And that you might have people who really do know stuff. They're really smart people, and they know the thing that they work on really well, but that doesn't answer the big question. And it was after a couple of days of this sort of not really things not working out, that I sort of just put to the group, picture this. I've been taking notes on what people are talking about when they're talking. And it looks like, and you could group them into these 7 different things that they were saying, but because they weren't, I wouldn't say they weren't listening, but they weren't hearing what the other people were saying. It was almost like there were these metaphorical blindfolds. And so I said, what if we sort of map out what we're talking about, and then we go in those groups, and then we come back together and and talk about what we've seen. But now we each know what the other people are talking about. We don't think they're just talking gibberish because they're not talking what I'm talking about. And it worked a treat. It worked greatly, and that is really the basis for the 7-step methodology that we use in transition engineering, because it isn't just about engineering. It is transdisciplinary, and it's hard problems. And so even the way that we can work through that together is important. So
Yeah, I love that you add this, and you have so many different unique aspects I never heard before. Studying your speeches and going through it, I become a fan of transition engineering, because it's not just like something that you would say, it's boring. No, it's not boring, because it studies history. You go back in time 100 years, then you go to vision, and I'm a visionary entrepreneur. This is how I consider myself, or in the future, a futurist, because I many times live in the future and then get back to the present. And so going 100 years ahead to see, okay, where we should be, and we need to cut down fossil fuel usage. Okay, and now what we do with this to not create a mayhem inside the general population, who will see that this is just like a degrowth or something, and I will just like starve, or I won't have fun anymore in my life, and it will be so miserable. And you say, no, it is a different world. We need to adapt. If before we wanted to create something like, okay, we could reduce and then the fossil fuel usage, and then recreate something for the rechargeable and energy versions that we are having now. But today, the discussion is different. Today, we need to stop it, to cut it, because we are not in the same situation we were 40, 30 years ago, let's say. Yeah. And so if we go to Jack this time, and we will open up the dialogue, where I would also want you to just ask questions to each other. And welcome to our LinkedIn crowd, because we have many people there, over 14 I just saw before. And so please write everything you want in the chat, because we will monitor the chat and we will highlight your questions and everything you want to just add. But before that, to present Jack. So Jack Laken from Canada, you are an inventor, an entrepreneur, an engineer who found ways to create rechargeable buildings that could recreate cities to become net zero faster through a lot of innovation and just cutting out the mechanical parts. And Professor Susan here is a mechanical engineer and a professor. And so this is very, very interesting, because if you two unite your power, who knows what can happen on a global scale. One of your problems, Jack, as far as I know, and you shared it with us in our podcast and a little bit in the pitching session, is that old habits die hard, right? And not many engineers are open to new solutions, even if they have the test of time. And so go with us around your story, and where are you today with what you have for us as a solution?
Actually, it's interesting to note that Professor Susan actually started with the image of the 5 blind people. In fact, probably when she was thinking about it, it popped into my mind on the other end of the planet, because that is what I was actually thinking on more than one occasion, that everybody seems to be telling the truth, but nobody can see the big picture. And that is the fundamental problem. So being in the engineering profession, designing a variety of buildings with millions of square feet or square meters for Europeans in metric mode, thinking in metric mode, I noticed a number of things that we as engineers are predominantly supporting manufactured solutions. And there's always a pill for every ill. So if we want a better energy efficiency, then there are situations we have to over-insulate buildings, do better windows. If we want a better indoor air quality, now after COVID or during COVID, everybody became so aware of the indoor air quality and pollution, and that inside of the buildings could be higher than outside. What basically drove me to drive integrated solutions that eliminate a lot of manufactured solutions is actually thinking in more kind of global perspective, and it becomes an interdisciplinary integration of, let's say, mechanical systems with the building structure. And that led us to an interesting situation where we started to do it a little over 15 years ago. And we have done a number of interesting buildings, a variety of buildings in Canada, we've done in the United States, and we've done buildings in India. So in the United States, buildings were able to produce more than they consume. In Canada, in a colder climate, educational buildings predominantly heated with body heat of the students, and we have data to support it. We've done custom residential, where actually we've done one of the houses. It was tested in a wind tunnel. We just decided to test it there because they were kind of sitting in the path of tornadoes. So, and not that long ago, we've done a fairly large university that happened to be an automotive university, and they had their wind tunnels for testing cars. So we said, why not to test a house in a wind tunnel? So a scaled down model was created, and we discovered certain adjustments that have to be made. On the other hand, you see one of the issues is obviously in the engineering profession, it's very structured, and we really have more of a mindset problem rather than a technical problem, because everything that we are doing is well documented in various technical manuals. The issue is exactly with the elephant and the 5 blind people. Somehow, there is not a tool that can link them together in a cohesive manner. So once we start talking about, let's say, AI or artificial intelligence, it can do a number of good things. But if we actually don't have the base prepared in a proper way to really take full advantage of energy that surrounds us, which we can harness using ventilation alone. Most of the buildings don't even need heating or cooling for most of the year. Whereas conventional buildings and even the green buildings in Europe, if they are kind of following the BREEAM system, or in North America, the LEED rating system for more energy efficiency buildings, they become very complex. And that becomes a bit of an issue, because the maintenance people, it boils down to maintenance people. And many of them can begin to operate in a break-fix mode. Break-fix, it means I'm too cold, no problems, we'll fix it. I'm too hot, no problems, we'll fix it. It's too noisy, we'll look into it. But you see, a lot of it can be eliminated, because a lot of the mechanical moving parts we don't even need in the buildings if we actually drive it in a integrated approach, where the building structure starts to work like a rechargeable battery that can eliminate. Everybody knows Tesla, but in Europe, Mercedes and Bosch and many other actually they have battery storage as well. So we eliminate a lot of parts that we just don't need it.
We could also add here a question. I think that we can shift a little bit the format, and if it's relatable, you have a question here, Jack, about buildings having batteries, having a concrete that can work as an anode or cathode.
Oh, okay, as another cathode. Well, that's an interesting question. We didn't use it. You see, there are two kinds of energy storage. Obviously, electrical, which is electrical, and that's probably what it refers to, anode and cathode. But we're using thermal energy storage. It means heating or cooling. And coincidentally, on a 24-hour cycle, looking at the daytime peaks and nighttime lows, we actually see a lot of opportunities to harness free energy using ventilation alone. So the ventilation fan can work like as an amplifier of energy. The problem is, where do we store it? A lot of the techniques, they basically suggest to flush the building. Flushing the building is not a very efficient way to do it. If we have chiller-like temperatures and we can actually bring it in efficiently into the building and store it exactly where we need it, and then release it in a radiant mode, that actually, so the structure begins to radiate. So to answer the question about anode and cathode, we didn't do it, but I would be interested to learn what exactly the gentleman or the person that asked the question to follow up and see what they had in mind in a greater detail.
Well, I think you said storage, and people automatically think electric batteries or something.
Right.
It's funny that you mentioned your work here, because my last PhD student in New Zealand has just wrapped up her thesis, and it is on basically this, on we understand that heating, ventilating, and air conditioning, the ASHRAE standards, in a world of unconstrained energy, that's a great way to go. I was lucky enough that when I was doing my master's in energy systems engineering in Arizona State, there was a professor in architecture who was giving a course on traditional passive design of buildings. And that was just really cool. So I used to put my hand on the ASHRAE standards, and but after that I just thought, well, maybe we're going down a road that isn't going to be sustainable in the way that the architects build something that is just an energy hog, and then the mechanicals try to make it comfortable for people when it's inherently an oven, right? A big glass oven, basically, a solar oven, and we're just going to burn through the energy so much.
Right.
So yeah.
I totally agree with you. You see, it's a fine balance. It's a fine balance. You see, when we store a lot of energy in the concrete floors, obviously that becomes a very interesting scenario. In fact, we eliminate a lot of start-stop during the day. It's driven by controls logic that in a way creates dimmable comfort. Same like we can dim lights, we basically create dimmable comfort, because we have a floating algorithm that is actually trying to maintain the user desired set point temperatures that they like, and the differences of the heat gain or the heat loss is kind of gently compensated. The only time that, let's say, we work in a start-stop mode is when we charge the buildings at night, which is a lot more favorable conditions, and it basically creates the buildings like virtual power plants, because now if we go looking at the bigger picture in the master plan community setting, they can become energy sharing buildings, because we have so much energy stored, with temperatures, for example, in a cold climate with temperatures minus 15 Celsius, buildings don't need heating from 9 in the morning till 8 in the evening. So it's 11 hours. That's a lot of thermal storage there. So we can kind of avoid the power peak bottlenecks that energy grid is experiencing, and kind of virtually even expand it. And that is given. Now in a heating mode, in a cooling mode, we have seen plus 30 degrees outside temperatures. There was no need for cooling until 2 p.m. in the afternoon on the south side. On the north side of the building, basically we didn't need until 6 in the afternoon. But by that time, the office buildings or the educational buildings are not very active to begin with. So there is a lot of interesting strategy for AI to really optimize it, but we need energy storage in one shape or the other. So there are a lot of other add-on energy storage solutions, like the phase change materials. They call it PCM. Then there is ice storage kind of techniques, but they all add on pieces of equipment, obviously applicable to existing buildings, but it's add-on, it's kind of manufacturer-driven. But they are all mechanically driven. It's not kind of driven to harness low-grade energy like the body heat of people or the slight changes in indoor temperatures, let's say due to fluctuation between the day and night temperatures.
I'm super happy to see so much excitement and attendance rate on LinkedIn on this topic. People are interested in our future, and we have literate people who want to know more. It's funny, Jack, when we had our first conversation and you explained me your technology, and I said, wow, okay, interesting. And from someone who doesn't come from this industry, I said, okay, concrete. It's that kind of first question. Maybe some of the people also have outside, but concrete is polluting. So what are we doing with this? And then you explained me, but maybe it's better not me to say it, but you finding the best solution out of multiple evils, let's say. Why concrete, and how you discovered that this is the best solution you can have today?
Well, I guess this probably question is it directed to me or both?
Yes, of course.
Yeah. So looking at material properties or thermal properties of materials, it's well documented event. And even for those that remember the cartoons, Disney World cartoons with Flintstone, when he was kind of keeping a large stone in the sun and then kind of rolling in inside of the house for the evening and the night, that would release energy. So that was based on thermal properties. So ability to absorb and how much to absorb. So all of it is well documented. And if you open up any handbook or even Google it or look up on the internet, thermal property, it's all there. The problem is that there is no software that kind of does integrated solution that keeps changing dynamic software simulation, which we developed. You see, temperatures are changing outside. Also in the building, all kind of activities are happening. So there's a lot of moving parts that are happening. Even if we open up a window and close the window, or open up doors and closing doors, or people show up and people come and leave, all kind of things, turning on equipment on and off. So a lot of things happening. And that kind of the type of software that we have is kind of static in a way, or kind of very rigid, but it doesn't take into account like the dynamics of the that is happening in a building and outside of the building, in a way that we can actually leverage, and we have a lot of opportunities to do that. So thermal properties, well documented. And instead of me telling you how much we can store and what have you, on the internet you'll find a lot of sources.
And also, as far as I understood, is that you do need to have some compromises, and if the compromise is good enough in order to get to that net zero, then you do it. And so I believe that this is very interesting, and many people don't know.
So I believe the compromise is not to compromise in a way that basically nobody wants to compromise with the comfort in North America and in Europe. In Europe, actually, maybe a little bit more tolerant, because people can wear a sweater into the office or a jacket. In North America, they like to come with a T-shirt or a shirt in the office without kind of. So comfort is a very interesting kind of part. What is interesting is now we came to amazing. Your question leads to amazing kind of answer. It's the mindset. Mindset is the biggest roadblock today in doing better buildings. Building better buildings. We have all kind of rating systems. In Europe, there are a number of systems that do the green buildings. In North America, the same thing. Some of them are very complex. People are not very kind of willing to embrace it, and a lot of buildings that have been done, they just plagued with cost and complexity, and then basically some of the buildings may even not perform as predicted. So the mindset is the biggest thing, and to drive awareness and the kind of things that Professor Susan was doing in New Zealand. It should be done all across North America, all across Europe.
Well, be careful. You know what we did.
Okay, so I'm sorry, I didn't.
Well, at our campus, I mean, the transition engineering approach is to make sure that you always start with the problem, right? Dig the problem, figure out what the problem is. And in an engineering sense, that has to be particular. It has to be a specific place or situation or heating degree day profile, right? So there's an existing building. Right? We cannot build our way to net zero. We have a huge bank, this huge asset base of buildings already in place. So where my PhD student's been working is at a university campus where you have district heating. That's a nice thing, from a big coal boiler. So the net zero requirement is to downshift fossil fuel by 80%. So what she did was to say, okay, the buildings exist as they are. I go to the boiler house and I talk to the boiler man and I say, imagine that you were going to get 80% less coal next year. What would you do? That makes a very interesting question.
Oh, absolutely.
Because what it means is that you cut about 3 months off either end, where you have the spring and the fall, and there are some cold days, but they're followed by warm days. And that's when they fire up the boiler, because the old way of thinking is that whenever there's a cold day, we have to have the boiler already going and ready to meet that load. But then, of course, the buildings are heated up by the coal. The next day it's hot, so the windows all come open and you have to cool the place down. So just shutting down the boiler, except for the core cold winter when it really is cold, and only when people are there. So instead of keeping it going over the break, then you could get to 80% less coal, and there would be about 15% of the days when people would have to either put on an electric heater in their office or. And so we suggested scholars robes, right? Specially designed scholars robes. They'd have a hood, they'd have long sleeves, long legs. It'd be,
yeah.
At this
get 80%
point,
reduction in fossil fuel and see. Now cope. Now what do you need? But do what has to be done first, and then figure out how to make the rest work.
Yeah, it makes a lot of sense. You see, obviously, every geographical location or climate zone drives its own kind of specific approach. Obviously, the portfolio of existing buildings is huge. And to deal with them, some buildings, it's possible to do sensible retrofits. In some buildings, the amount of money that is actually has to be put in to retrofit may warrant actually demolishing and building a new super efficient structure that is more functional. And in Europe, may or may not be as applicable as in North America, because in North America, buildings are not designed to last 100 years or a couple of 100 years. Some buildings are designed, we've been involved, buildings that basically would last for 25 years. And after that, it's a demolition. So
I also heard this term of retrofitting from our friend Richard, who was also part of our summit, and it's so interesting to think the word that we are now at an interesting point, to say it mildly, where we need to reconsider things, but also check the past, because there are regions that are just shifting now, and what we have buildings suitable for 1 decade ago, it would be suitable for another country now. And so how you can retrofit, future fit things in a way that you adjust to the climate change. Yeah.
Right. So, we came across, for example, in California, they have millions of square feet of single level schools, single level. Some of them were built 50, 60, 70 years ago. Some of them don't even have insulation in the walls. So the single level schools, it could be a very straightforward retrofit to remove the roof and replace it with a climate smart roof. What it means, it basically could have the year-round thermal energy storage. It means it can store cooling or heating, and at the same time can have solar kind of integrated into the roof. Because even if we want to add solar today on these roofs, they will not hold the weight. They may end up on the floor, because it will, just the weight alone. Because in California, they don't have snow, they don't have, hurricanes and what have you. So the roofs are very lightweight, and they cannot support solar to begin with. But the equipment is old. The roof equipment, heating, cooling equipment, and they use 3 to 4 times more energy compared to what basically a good school could use. And if we add solar, in fact, even less solar would be required. The climate there is kind of quite conducive.
Well, do you think we have enough building system engineers? It's like such a no-brainer thing to do, to work through every building and make sure that it is adaptive, that it makes the most sense, that it is fit for purpose. Maybe even we need to change, maybe even that building needs to change what it's used for, because things are different post-COVID, so if I look at the number of energy engineers that we need, I don't see that we have enough. We never have really since the 80s.
Yeah, absolutely. You see, the energy engineers are the ones that basically I'm familiar with, mostly in North America and Europe. Probably it's similar. They're basically influenced by manufactured solutions. So we're getting back to we have a pill for every ill. So if you need this, we have it. If you need something else, we have it. You see, what happened is I believe that we kind of elevated ourselves into, if we compare to a medical profession, if somebody comes, an engineer is basically assumed to be the ultimate authority. If he knows heating and cooling or the indoor comfort systems, he's the ultimate authority. So if, let's say, specialized people like us show up, sometimes they feel that it's like there are 2 cooks in a kitchen and they don't like it. So, and the decision makers rely on their engineers. So it goes a little bit on the merry-go-round circles, to your point. And what we do, we guarantee. It's not like we're practicing. We've been doing it for 15 years, more than 15 years in Canada and the United States. Construction is a very litigious field. So, and there's a lot of disputes that can happen for whatever reasons, and doing what we're doing may put some engineers also a little bit in the discomfort zone, because we tell them we need half of the equipment.
They need to learn new things.
Absolutely.
So that's all right. They can learn new things.
I guess you see, Professor Susan, we need, now as we are getting into artificial intelligence, we need a lot of digital twins of you to be talking to many people at the same time.
This is a great idea. And just
Well, I
I
have
want to
written a
acknowledge-
book. People can read my book.
Yes, she has a book on transition engineering. Please read her book, everyone. And I
I
want
put
to acknowledge
cartoons in it.
I'm using it. Susan, I always forgot this, but I had this question on my mind with our previous panel as well. So you went through all of the sustainable energy sources. You tested them and you went through decades of seeing what can become more suited and not based on ROI, a very important word.
Yeah.
ROI. And so
Absolutely.
you discovered, I truly want to clarify, because you mentioned in some of your talks that, for example, hydrogen, that it's something very cool these days. It's not, it doesn't have the right ROI, and that might be destructive and very depressive for some people. Also biofuels. So please, today, what you know, based on what you know, which sources truly present a case for we to become net zero positive in 2030, and which should be out of the question starting today?
All right. Well, that's a pretty easy answer because right now, the net zero transition, the absolutely best energy source is the fossil energy we don't use. It's called efficiency or
Yeah.
demand management, or do
Yeah.
that better, or don't do that dumb thing, whatever.
Absolutely. And just to add, basically, if we adopt the mindset of do more with less, and harness the free energy that surrounds us, whether during the day, like in Canada, as I mentioned, schools are heated in the winter predominantly with the body heat of the students. In other places like California at night, they have chiller-like temperatures. So they have 14, 13 degrees Celsius, 15 degrees Celsius. So the ventilation fan alone at night can draw in, with 1 unit of fan power, can draw in more than 1 unit of cooling. So it kind of, and it's cleansing the building at the same time, because cleaning in educational buildings happens at night. And, all these toxic cleaning agents or components, are flushed out. In fact, what's interesting, that brings up another kind of project that we've done, medical building. We've been doing exactly that. In the medical building, the cleansing is very intense, after hours. And by charging it at night with fresh air, it was done in Toronto, Canada. At night, chiller-like temperatures. So we flush it out, and at night, the outdoor air quality it's much better than during the day, because during the day, the pollution goes up. So when they open up the doors in a medical clinic, inside of the clinic is much fresher than outside. And by the way, this clinic was open during COVID and was treating COVID patients for one simple reason. They did not recirculate any stale air. Fresh air in, stale air out. And the reason why we recirculate the building is to save energy. Because we don't want to kind of preheat or pre-cool the outdoor higher temperatures. So that's why a lot of recirculation takes place in the buildings.
We do have an issue, though. Have you seen what is happening to the nighttime temperatures? This climate change, global warming thing, I mean, I grew up in Colorado, and the nighttime coolness, you've got that clean sky, the clear sky, the clean air, and you almost really don't need air conditioning. Well, of course you don't need it. You haven't had it until the last 30 years or so. But you got to have shade. So you got to have trees. You got to have a reasonable sized fenestration. So the windows, not those giant windows that we love facing the west, where the setting sun can come streaming in. So you got to get your windows reasonable sized. You got to get sort of deep wells so that you have shade on the window a lot of the time. Getting overhangs. What happened to overhangs on the roof, the eaves? So there's just lots of common sense that we used to know. Absolutely. So Carissa just asked about, in developing countries where maybe they haven't built all their building stock already, and that's not their problem. How do you do it right the first time? How do you bring in these things? And I did do a research project in Guyana, and I would say the first thing to do is step one in transition engineering, which is go back in time and just learn from people who have been there for a really long time, who have tried lots of things and have settled on something that works pretty good, and ask yourself, what about that works good? Why is that what they've been doing? And there's a lot of experimentation and learning in the traditional building forms. So do that first. And then heat transfer.
Yeah, absolutely.
Sure
in fact, to your point, it's interesting that in Guyana right now, because they discovered a lot of oil and then all of a sudden they're super rich or about to become rich, they actually planning a smart city, and obviously they have to deal with the energy infrastructure. And what's interesting, altogether,
they really don't have renewable options there. They're using bunker fuel, big diesel generators to generate their grid electricity. That's right. So housetop solar is about it, but man, it's very hot. And so you have to do the passive design first.
Yes, because they are kind of in a kind of semi-tropical kind of climate where humidity is a big issue as well. So yeah, but altogether, in Latin America, they actually like to build buildings from concrete, and obviously, if they do that, then obviously they can take advantage of the thermal energy properties, or kind of to introduce with ventilation fan a lot of coolness or into the space, because heat they don't need for most of the time.
And back to our ways that we can think about solutions. What do you think about geothermal? Because I see that this is something that it's happening for a while, but now it looks like a trend that it's increasing. And I just heard at the climate summit in Miami talking about solutions that they should go to the next level. What do you think, Susan, about this? Is this a real solution?
Going to the next level? Sorry.
Yeah, with geothermal. Because we just used a very small fraction of it, but there is a huge amount. So some says that it's very dangerous. So this is the angle of my question, that we don't have the tests, and if we are ready for such a huge endeavor around the world, because the same.
Well, let's just deal with that. No matter how much Jack and I talk about its efficiency, we're not going to stay there. We're going to go, okay, but we need more energy, right? So okay, fine. We'll go there. And there are places where geothermal power generation works. That's where you've got volcanic activity that you're living with, where you've got earthquakes that you're living with, and New Zealand is an example, and Iceland. So where you have volcanic activity, where magma has come up close to the surface, has heated a lot of rock over millions of years, and where there's been lots of earthquakes, so that ground has become fractured and it's now full of water. And so that water is the heat source. It's the water that's been heated. And so you can drill holes, bring that water up, use the heat, and put the water back down the hole. You do have to do that. Now, be aware that when you pull that water up from depth, so it'll be 1.5 kilometers to maybe 3 kilometers, it will be full of minerals, because it's been sitting there in hot rocks that were magma for a long time. And so some of those minerals might be valuable. A lot of them are not. They are toxic materials, so they need to go back down the hole. And that type of electricity generation is known, and Africa has a pretty interesting amount of that. So does anywhere in the Pacific Rim of Fire. So Chile, Peru, maybe Ecuador. So there definitely are places where you can do geothermal energy. All right. Well, there's another thing that's called geothermal energy, which is ground source heat pumps. And if you're in a temperate area, then that doesn't make sense. The the outdoor air has enough heat in it that you can use it. If you're in Minnesota, good luck with that. You want the heat in the winter and it's not out there, so you go down into the ground. Well, that adds a lot of expense, a lot of materials. The other geothermal that people are talking about is new stuff, like, okay, we know the center of the earth is really hot, so can't we drill down farther until we actually get to where it is really hot, even if we don't have volcanoes and earthquakes? And the answer is, sure, drill yourself crazy, right? Just go for it. Drilling is known. Drill. Problem, heat transfer fluid. That's the problem. You now have to get a heat transfer fluid down that hole, have it interact with the hot rock, and then come back up. And the volume that you can do in a hole that you can drill down 5 miles, and the time that it takes to heat up, and then of course it's going to cool as it comes back up. There's just not been a practical way to do that, to move that heat from that depth up and to have it get hot enough, because you've just drilled one little poke hole, whereas in geothermal zones, nature has created a whole geothermal reservoir for you. So yeah, energy return on energy invested of deep hot rock, not good. It's barely there for geothermal. When you have a thermal reservoir, it's not great, you know.
Just to add, obviously, Professor Soon kind of described the various kind of understanding what geothermal means. So coincidentally, we've been involved in ground source heat pumps. You see, it was a choice of not our choice, because we use any kind of equipment that basically the client prefers. But we had several instances where ground source heat pumps have been used. One was used on the Canadian side in a fairly cold climate. But the interesting part is, using our solution, we need about half of the drilling into the ground, because the drilling is a very expensive proposition, besides the fact that we needed smaller equipment. So the cost and payback of these ground source heat pumps was kind of cut in half, because that's their major problem. The other one that we've done, actually, it was the largest portfolio of buildings that we've done, about 750,000 square feet, net positive development. They actually used geothermal ground source heat pumps. Some call it geothermal, but that's, kind of can get mixed up. So we reduced by 42.8%, because it was a hot and humid climate, so it created some more kind of interesting conditions in doing that. In fact, they listed in the Guide to Net Zero by the U.S. Department of Energy, National Renewable Energy Labs. I believe it still remains the largest net positive development in the United States.
Do you have any numbers about how much energy do we use from the earth energy? I'm asking this because we discussed the Kardashev scale at our first post-summit discussion with Maura de Clark Mândrilă, and we were thinking, okay, we are on level 0 as humanity in evolution with our energy resources utilization, and we are getting to level 1, but that means that we use the entire earth energy. And I wonder where we are on this scale, because we need to put the fossil fuels in the equation. Okay, that would mean fossil fuels, and we have a lot of them, but we just blew up the earth. So how can we balance this, where we are in this journey to get to a level 1 civilization, in your view?
Yeah. So
yeah.
Okay, let's say on the data that I have available, in fact, there is some research. It's a little outdated, because it kind of requires a lot of resources.
Data acquisition, and
right. So I can share one of the reports created by several PhD professors in Canada, and they did a global overview of how much energy buildings are consuming. By now, it's still a fairly relevant source. I'm happy to share a link to it. And what's interesting, our buildings have been rated best performing from the entire portfolio, except that for some reason Hong Kong and Portugal came out better performing than our buildings, but they are kind of in a different climate zone, so there was no adjustment made to a common source of reference how they perform. But energy use intensity in our buildings is extremely low.
Okay, we will go a little bit overboard if it's possible. 10 minutes. We started a bit later, and because our community is so engaged, they would want us to stay 1 hour more. It's an interesting discussion. We covered so little, but let's focus on the story and the narratives. And because Susan, you are focused on this as well, and we moving further as TLL, as the new direction, we are focusing on aligning our stories about the future, because this might unite us globally. And you mentioned this a couple of times. For example, Danielle is asking what new stories we should tell ourselves to take action sooner. This is an important question. We should find answer. What do you think?
All right. So the story that looks like we have a future, I think it looks like an explorer, right? We've become quite complacent. We haven't had really new things to explore for a long time. We were pretty excited about ourselves when we were going to the moon and going out into space. And every once in a while we talk about Mars, but now that's a rich guy's escape or something, or just a cool movie. It doesn't seem real. So us exploring our own future, maybe that's the story we ought to tell about ourselves. And to do that, it means we have to, like all other past explorers, we have to take a big leap. We have to get a ship, fill it up with a crew and whatever we think we're going to need, and we have to go, right? We have to sail off. And so what does that ship that gets us to a safe future look like? Well, it doesn't look like we're going to a Club Med, does it? It doesn't look like everything we need is going to be there because we want it to be. It looks like it's going to take ingenuity. It looks like it's going to take work. It looks like it's going to take new ideas. So off we go. And yeah, it looks like what we do is we downshift fossil fuel by 80%. That's it. That's the new world to explore. So
we start to align everyone that we need a complete mindset shift. We need to be able to create this. I also love the discussion with people. Okay, how?
Well, it's a mental game first, isn't it? You don't build a bridge without the mental game first, without creating the design for the bridge, without creating the space. And so this going to the fossil-free future, that's a game to play first. And right now, that is the fun part of transition engineering, because while we can say net zero target, we're not really actually in the game yet. We're not thinking about it. We're not asking, okay, what would that be like?
You are so right. And these discussions are nowhere in the mainstream media or on social media. And when we can create very quick shifts in our mindset if we shift the story, and you will see it everywhere, because we can start crying for a baby or a child who disappeared if that story goes mainstream. How about creating the future mainstream story about how we can live in a wonderful world where fossil fuels are not used anymore, or they are used in 1%?
And if there are people exploring that right now, wouldn't that make fun stories? You want to see what it looks like?
Yes, and this is what we are on right now, and we are starting to go in this direction with TLL, and everyone is invited to join, because we want to figure out this kind of future story. And before ending, let's just discuss something important between you and Jack. How do you see now, after this discussion and dialogue, that if you would unite your forces in a way that you bring the new line of transition engineers with you, and you say, okay, for the next X amount of time, we will just push adopting Jack's technology for all of those cities that are suitable for what he has. How could this be a possibility?
Well, you've got two things. One is the opening up the space in which you just do the thing that needs doing. So there's lots of solutions. There's lots of it's called engineering, right? That you do what would work. Engineering means making something work using science and an affordable budget. So the thing is, what is the project? And that's where we're all kind of stuck, is what is the project? There's so many things we could do, but we're just doing the same old thing anyway. So that shift of the mindset to the new project. And that, I guess I should mention, transition engineering isn't like a whole new field. It is a corrective discipline in every field, right? So it's like safety engineering. There are hard hats because somebody thought, oh, wait a minute, people are getting their heads smashed. But hard hats aren't the answer to safety engineering, right? They're just part of doing the right thing, not being dumb. All right. So transition engineering, it's not like you have to stop what you're doing and only do that. It's like whatever you're doing, ask yourself, okay, so what if they turn the gas down 80%? What if the amount of petrol coming into my county next year was 20% less? Are we ready for this? Are we ready for this big journey to net zero? No? Okay. What do you need? What would you do? Start thinking about it. Don't think about solutions. Think about what would you do?
Yeah, this is the beauty of your field, because you take all of the solutions that exist, and I believe you do have a real-time kind of system, right, where you monitor.
But you want the things, if you don't mind thinking metaphorically, picture that galleon, right? Maybe 3 of them, maybe you get 3 to go off and explore this new space. And you have to decide what goes in the ships that you're going to take with you. And that's where things like hydrogen, we love to say, oh, it's part of the solution. Yeah. Can it fit in the boat? The answer is no, it's not the thing you would take. You got to be really judicious about what makes sense to take with you as you go explore and build this new world. And don't colonize anybody. We got to recolonize the old world. Really, it's a
great point. It's important for us to think about a multiplanetary species, for sure, for our evolution, and we need fusion for that to sustain our future spaces and so on.
Right. But exploration, it really isn't about solutions. It's about really honest, clear-eyed thinking about what you're going to take with you and who you're going to take with you, what skill sets you need. And that skill set is adaptability. It's ingenuity. It's being able to problem solve on the fly. It's being able to be aware and looking and learning from what you find as you go along. So that's that explorer mindset, as opposed to, I have a solution, you should buy my thing. I don't know, what's the problem?
And you also need a long line of astronauts, like transition engineers, for all of these new steps. Some are part of
true. I'll train you up if you want. We have online classes. We do have an elite squad. So if you want to take a year and come to Orkney and learn to be a transition engineer, go to the end of the planet, take a year, become a real transition leader. We've got 10 spots
everyone who's in this space
program for next year.
I truly can advise, because this is the future. I cannot see how this is not the future of engineering. If you want to go net zero, you do need these skills that you are learning inside. So it's absolutely fascinating. I would advise everyone who is an engineer and wants to expand in the future to go and take these classes and read Susan's books. And final words from you, Jack. How do you see we could end this conversation with something actionable before we move to the next stage? Because you are invited back for sure.
Well,
both of you.
So obviously, Professor Susan kind of summarized it quite nicely. And we should be focused on how to do more with less. That was actually our mindset to begin with. And when we say how to do more with less, it's not to compromise comfort, safety, reliability, and just leverage the free energy that surrounds us. And using concrete as a rechargeable building could be one of the potential solutions. Obviously, it's not a magic bullet for every single case, but in many cases, it can be quite a valuable part of the equation on driving carbon neutrality.
Thank you so much for this discussion dialogue. Awesome. Susan, extra thank you because you answered the questions in the chat while having a live. You have this multi-skilled personality. You did this through the summit as well. So everyone received an answer to all of the questions. Please, if you joined us later, subscribe to our newsletter and get that consensus document that is our result and product after the summit. This is the first step that we are doing now, also during the post-summit dialogues, where we are matching people who might create a global impact if they unite. And this is the philosophy of Tech Leadership Lab. We want to unite entities of all sorts globally, no matter who you are, where you are, what's your age, what's your sex. We don't care. We want to become a united species and humanity to unite for a global common purpose of having the same or more with less, no matter how, but in a sustainable way where our children and the future generations can also live. And with that said, please, if you want to join our movement of creating an impact and solving all the SDGs sooner, just get in touch, subscribe to our channels, be involved in everything we are doing, because we are on the verge on a huge leap. That's what we want to do with our next summit and the next steps that we are now preparing. And with that being said, thank you again, Professor Susan Krumdieck and Jack Laken. And see you next time with us. Have a wonderful day and a wonderful week ahead. Still a couple of days.
Sure.
Yeah.
Thanks for having me.
Thank you.
In a world yearning for change, there exists a community of visionaries and innovators, united by a common goal: to solve Earth's biggest challenges. From climate action to quality education, we're tackling all 17 Sustainable Development Goals reassembled as 10. We embody sustainability, unity, and empathy. Our character and reliability shine as beacons of hope. As role models for future generations, we're building a world where wisdom and consciousness rise, harmonizing life with nature and all species. Join us. Together, let's create a balanced, sustainable future for all.